Welcome students to the 11th lecture of Logic and Distributed Control System. So today we are going to discuss rest of the part of PLC timer functions. So last class we have discussed about the fundamentals of timer functions and the categories of timer functions like on delay, off delay, retentive, non-retentive, along with some examples we have studied. So today we will discuss rest of the examples, which is very important to understand the different application of timer functions. So this is the next example we are going to cover. So the theme is that an output pulses on and quickly off at a constant preset time interval. So this is a very important application of timer. Later on we will see that if we want to create a short pulse at a constant preset time interval, then this will be very helpful. So the problem statement is that that in a paper mill, as finished paper comes out of a paper machine to the finished roll, a roll number is to be printed on the edge at intervals. It is determined that the number should be printed once every 12 seconds. So a short printer head means a printer head will come and print the roll number, okay, for a moment, and then it will go back, and after 12-second interval of time again it will come and print the roll number. So like that we want. So let us see that how it can be done. So here is the programming. Now you can see here that that preset is given for the timer. Preset is given 12. Fine. Then IN005 is the run. Okay, and the reset enable, that is the very important here. Reset and enable, you can see that the output coil of the timer T013 has been used as a normally closed contact. Okay, so how this is going to work? And so suppose IN005 is closed, fine, and already T013 is off. So initially it is off, so definitely it is closed. So now the timer start to count. Okay, fine. So now that's why at IN005 when it is closed, then it is closed forever. Fine. Now what will happen after 12-second time? So when the 12-second is elapsed, then T013 is going to be on. Once it is on, you see at the 12-second interval of time it is on, and it will on momentarily, because what will be the moment during which it should be on? During the scan time. So after the one scan, what will happen? That the timer will see that it is already on. Once it is on, then T103, which is used as a reset switch, it is going to be off. Once it is going to be off, at that moment of time, the timer is going to be reset. Once it is reset, then it will come down, and then what will happen? Once it will reset, then again the T013 is going to be off. Once it is off, then T103 will be in the reset line, enable line, it will be true. So then what will happen? It will count another 12 seconds, means after 24 seconds again the same phenomena is going to happen. So here is the explanation is given. The timer T013 is set at 12 seconds. When the paper machine is turned on, IN005 closes. With the timer input IN005 on, the timer runs for 12 seconds. After 12 seconds, timer goes on, and its output actuates the print head. The timer then, after one scan, immediately shuts off through the opening the T013 normally closed contact in the timer enable line. Once the T103 goes off, it resets the enable contact to close, and the 12 seconds timing cycle is repeated. When a paper roll is completed and the machine is shut down, IN005 should be shut off. So this is a very important application of timer. You will find later also that how to create a short pulse at a regular interval of time. So now one short operation based on this idea, we want to develop another programming, that is output B goes on for a specific time after output A is turned on. Output B will run for its specified time interval even if A is turned off during the B timing interval. So an alarm, so based on this theme, one problem statement is stated here. An alarm is to sound for 17 seconds after a machine is started with push button switch IN001 to alert personnel in the area that the machine has been started. The alarm goes on when the machine is started. The alarm stays on for 17 seconds even the input is turned off during 17-second time period. That is the most important time. Alarm stays on for 17 seconds, and during 70 seconds even if the input is turned on off, that the alarm should ring. The machine could be coasting down. IN001 must be opened to reset the system. Fine. So now here is the timing diagram. As I told you, the timing diagram will help you to do that one. So you see, if we will assume that the CR30 is the machine, so when the machine is turned on, at that time the alarm is also turned on. Fine. And the machine is turned on by a switch IN001. Fine. Now it is continued to be on for 17 seconds. After 17 seconds it is going to be off, and in between if you off the IN001, then the machine is also not going to be off, and also the output alarm is not going to be off. That is the thing you have to develop. So here how we can do that one. Now here we have taken the switch IN, and another thing has been told that IN11 must be opened to reset the system. Okay, so let us take IN001 is the input switch and CR30 is the machine. Fine. So now if the IN001 is on, okay, CR30 must be on, and condition is that even if IN001 is turned off, then machine should not stop. So that's why what we will do, we will use the latching concept. So CR30 has been latched. Now we are using one timer with the 17-second preset time, where you can see that the run input has been indicated by CR30. So whenever the CR30 will be energized, this is going to be closed. Fine. And here the IN0011 has been taken, means the enable and reset has been taken as a normally closed. So once it is closed, so the TS30 is going to start to count, but at the duration of 17 seconds this TS31 is off. So that's why what we will do, we will use a negative logic here to energize the alarm. So TS31 we have taken normally close, and once the CR30 is energized, so definitely it will be energized. And now you see that once you will close the IN001, then the CR30 is going to be energized. Forget about this. Actually here one mistake is there. Okay, forget about, suppose it is not present, this TS31 is not present. Okay, simply it is connected. So then if IN001 is closed, then CR30 is going to energized, and then CR30, if it is energized, it is closed. It is already normally closed. So the timer start to count, but TS31 is de-energized. So that's why TS31 will be closed, and CR30 is energized. So it is closed. So at that moment of time, the alarm is also going to start. fine. But after 17 seconds, what will happen? After 17 seconds, TS31 is going to be energized. Once the TS31 is going to be energized, here it is going to false, the alarm is going to off. So that condition we can develop. TS31 is going to off. But another thing has been told that if another thing has been told that even during the interval of 17 seconds, if IN001 is going to be off, then nothing is going to happen, means machine is going to run and also output is also going, means the alarm is going to run. It is true, you see, if you withdraw IN001, then due to the latching operation, CR30 is going to be still energized. If the CR30 is going to be still energized, then what will happen? This logic is going to be true during 17 seconds, and then output is still to be energized. Okay, and after 17 seconds, TS31 is energized, and then TS31 here in this rung, last rung, it is going to be false, then output is going to be off. And the last thing is that you have to reset by a switch IN001 such that machine is going to be off as well as the output is going to be off, means alarm output is going to be off. So that can be done by IN001. So once it is open, then the timer is going to be reset. Okay, timer is going to be reset, and here one thing we can do that we can add a normally closed switch with IN001. That is a mistake here, it was IN001. So once, sorry, IN011. So now once this has been withdrawn, then what will happen? This will be withdrawn, and if this is going to be false in the first rung, then the machine is going to be off. Once the machine is going to be off, this also going to be off, means the output alarm is going to be stopped. So this way we can develop the logic what it has been told in the problem statement. Now another application we will see, that an example of this timing application is two alternatively flashing signal lights. The time on for each of the two lights may be the same, or the two times could be set to different intervals. Means we want to alternatively make on and off two lights. So problem statement, you see, you have a warning light system on a machine to indicate it's running. A single flashing light is not deemed sufficient. You want to alternate two alternating lights, output CR11 and CR12, to control the two lights. That two lights alternate every half second for the timer. IN001 is the master on-off control. So half second interval of time, the CR11, CR12 alternatively going to glow. Fine. So what will be the timing diagram? Let us see the timing diagram. So we have two lights, light A and light B. So whenever the light A is off, then light B must be on, and this duration we have said that 0.5 second. After 0.5 second, the light A is going to on. At that time, light B is going to be off. So in this way, it should be repetitive, and there must be a master switch such that we can off the whole system. Fine. So how we can do that one? So let us see how it can be done. So here we have the light A and light B, which is indicated by CR11 and CR12. Okay, so we have the master switch IN001. So IN001 is the master switch. IN001 is here, IN001 is also here. Now we will perform this operation using two timer. Fine. So first timer we have taken, you see, first timer we have taken with the preset value 5. Second timer also we have taken with the preset value of 5. And we are assuming that 0.1 is the smallest increment. So it is actually the when the accumulated value will be equal to the preset value, then after 0.5 second interval, this TT259 and TT260 is going to be energized. Okay, but here most interesting thing is that in the enable and the reset line, you can see we have used with the master switch IN001, the address of the second timer T260 in a normally closed, and here in enable and here it is actually run, it is run and enable we have used with the master switch IN001 TT259, which is the address of the first timer. Okay, so now you see how it is going to operate. Let us understand that one. So suppose first IN001 is closed, so all the IN001 will be closed, and at that moment of time you can see what is the condition of the first timer. So it depends on the TT260, which is normally closed. So at that moment of time, what is the condition of the 259? 259 is off. If it is off, then here in the reset and enable line, both the switches will be off. If both the switches are off, then TT260 is de-energized. If it is de-energized or it is off, then what will happen? It is true in this line. If it is true, then actually TT259 is this timer starts to count, but still this is not going to count, and that moment of time TT259 will be off and this TT260 also will be off. If these two are off, then the light A will be off, light B will be on, because TT259 is used as a normally open and TT259 in the next line it is normally closed. So if the TT259 at that moment of time is off, then it is true. It is true for the both cases. It is normally on and it is normally off, so that's why light B is going to glow and light A is off, so which has been shown in the diagram. You see at the logic TT259 is off at this moment. If it is off, the light A is off and but the light B is on. So now it will continue. So we want to see after 0.5 second what is going to happen. So after 0.5 second, TT259 is going to be energized. Fine. If the TT259 is going to be energized, then light A is going to glow because it is going to be closed, but at that time TT259 in this line is going to be false, so light B is going to be off. So first we see the lights. So that's why you see after 0.5 second interval of time, CR11 is going to be on and the CR12 is going to be off. But what will happen to the next timer? Now when it is going to be energized after 0.5 second interval of time, then what will happen? It is going to be true at that time. Means now the TT260 is activated, means it will be activated after 0.5 second, means total time interval will be 0.5 plus 0.5 means 1 second interval of time. But now we have to see that after 1 second interval of time means another 0.5 second interval of time, what is going to, so 0.5 after 0.5 second this TT259 is on and it will be continued to on for another 0.5 second, and we want to see after 0.5 second what is going to happen, because at that time the timer 260 is going to be activated. So now after 0.5 second of interval of time, TT260 is going to be activated. Once it is going to be energized in this moment of time, then what will happen? Now it will reset the TT259. If it will reset immediately, the TT259 is going to be off. Okay, once this TT259 is going to be off, then what will happen? Now this in this line in the second timer, this is going to be off, means T59 is going to be false. Once the T259 is going to be false, means this timer is also going to be reset momentarily, means it is going to be off at that moment of time. You see, that's why at the 0.5 means a total 1 second interval of time, 260 is also going to be off. Once the 260 is going to be off, then what will happen? Now, already we have resetted TT259. So if it is resetted, means at that time light A is going to be off and light B is going to be on. Okay, so now the same thing is going to happen another 0.5 second interval of time, that 259 is again going to be energized. Fine. So in this way we are going to repeat the cycle, and the light A and light B going to be on and off for a particular duration of time, that is 0.5 second interval. So in this way we can develop the problem which is ladder logic, we can develop the problem which is given. Then multiple on delay. Theme is the multiple on delay. The two different events start at different time intervals after an initial starting time reference point. So let us see the problem statement. A metal bar is held in a fixture and shaped by three hydraulic press operation. So close IN001 to start. Then hydraulic press A, which is indicated by CR17, presses in and stayed in the press position. After 7 seconds, a second hydraulic press actuator B, CR18, presses it from another direction and holds position. Finally, after 12 seconds, a third press actuator C, CR19, comes in from a third direction and holds position. So opening IN001 releases all three presses so that part may be removed. For 3 or more time delays, continue to use more cascaded additional timer function. So this can be done by two ways. So here you see we are using two timers. One is preset value is 7 and another preset value is 12, because once if you'll see the timing diagram, so once the IN001 is on, the CR17 is immediately that is CR17 is the first hydraulic. Okay, so it immediately is going to on, but CR18 and CR19 and 18 and 19 immediately is not going to on. CR18 is going to be on after 5 seconds and CR19 is going to on after 12 seconds. Okay, so how it can be done? Now you see, if the IN001 is closed, so this is closed, this is closed, fine. Now CR17 is going to be on, and if you at that moment of time, if you close IN002, then the timer starts to count. And here you see, for the space saving purpose, two things are written together, TS and CR18, means after 7 seconds TS is going to be energized and it will energize the CR18. But in your exam you should not write in this way. I will prefer to do in this way. So you will extend this. Suppose another line you will use, that is you will give TS18, okay, and another output you will indicate, that is CR18. So after 7 seconds the CR18 is going to be on. Similarly, what will happen, that after 12 seconds, so here another line you will add, that is you will write TS19 and the output you will write CR19. So after 12 seconds CR19 is going to be on. Other way you can do, if you write the preset value for the first timer is 7, you can write another time the preset value is 5, provided that the TS18 or the CR18 address, TS18 address will be used as a run switch for the second timer. Then what will happen, after 7 seconds when the TS18 is going to be energized, then CR18 is going to be energized, and then it is going to be true, and then additional 7 plus 5 seconds means 12 seconds after the TS19 or CR19 is going to be energized. So in this way you can have the ladder diagram for the problem what we have indicated. So next we are going to understand motor sequence, how we will suppose three motors have to be on in a sequence. Okay, so let us try to understand. So here is a push button switch start. So once it will start, the IR is going to be start, even if you withdraw the start button, so it is latch, so then it will be going to be on. So IR1 is going to be energized, and IR1 is used as a the run and enable switch for the timer. So it is going to be on, this is going to be on. Okay, once the IR is immediately is on, then the motor 1 is going to be on immediately, but motor 3 and motor 2 and motor 3 is not going to be on immediately. It will depends on the time T1, what is the timer T1 you have given for the first timer. So suppose after T1 interval of time, IR2 is going to be energized, so IR2 is going to be closed. At that moment of time, motor 2 is going to be start, and suppose another time interval T2 you have given, so after T2 interval of time, IR3 is going to be on, so here it is going to be energized, means it is going to on the motor 3. Fine. And if you want to stop all the motors, then if you withdraw this stop switch, then what will happen, that it will reset all the counters, all the timers, such that motor 1, motor 2, motor 3 is going to be stopped. So in this way you can start the sequence, start the motors in a sequence. Fine. Now we are going to understand multiple of delay functions. So two different functions remain on for two different time intervals after a process is turned off. Let us try to understand one situation. The problem statement is given when IN001, which is push button, is on, the building lights, exit door lights and parking lights are on. Fine. And when the building lights are turned off in a building, a exit door light is not going to off immediately. The exit door light is going to be remain on for an additional 45 seconds. In addition, the parking lot lights are to be remain on for an additional 3 minutes after the door light goes out. So let us try to understand with the timing diagram. You see, once the main switch is on, then building light, door light and the parking lot light is going to be on. Okay, and it will be on remain the duration what we want. So once the main building light is off, door light is not going to be off, it is going to be on for additional 45 seconds, and the parking lot light also is not going to be off, it will be on for additional 225 seconds, and after that it is going to off. Okay, how we can develop this logic. So let us come here. So suppose IN001 is the master switch, so IN001 with that CR17, which is the main operation. Okay, so now we have the building, so you can write the building light, then the door light we have, and the parking light. Fine. So now when the IN001 is closed, CR17 is going to be energized, means the building light is on. So here if we will on the IN001, so CR19 is going to be energized, because at that moment of time you can see once the IN001 is on, this timer is not going to be perform because it is going to be off. So they are the negative, they are negative logic. So CR18 is going to be off. Okay, so now CR18, if it is off, so it is true here. So now the CR19 is going to be energized, and once the CR19 is energized, it is last by this operation. Fine. And similarly, IN001 when it is on, then what will happen for another timer, it is also negative logic at that time, so it is not going to be in operation. So TS20 is going to be off. Once the TS20 is off, so due to this IN001 and CR20 is off, so 21, the parking light is going to be on. Fine. And here the latching has been done. So why the latching has been done? Suppose if the IN001 is withdrawn, if the IN001 is withdrawn, then immediately the building light is going to be off. If the building light is going to be off, then at that moment of time these two become true and this also become true, means this timer and this timer starts to operate. Fine. And if we withdraw IN001, the door light and the parking light is not going to be off. Due to what? Because due to the latching. Because even if this IN001 is withdrawn for the two cases, this is going to be on, because still the CR18 is false and CR20 is false. So due to that, both the lights will be on. Fine, but the door light is going to be on for 45 seconds, because after 45 seconds this CR18 is going to be energized, which making this switch false, means door light after 45 seconds it is going to be off. And similar thing is going to happen for the parking lot light. After 225 seconds, that CR20 is going to be energized, which make this this switch false, so make the parking lot light off. So in this way we can realize the problem statement what it is given using ladder diagram. So now we will now discuss the last example for this timer operation. We may require that an output come on for a particular duration, say 7.5 seconds after system startup, remain on for another particular interval of time, that is 4.5 seconds, and then go off and stay off. The interval would be repeated only after the system is shut off, then turn back on. Fine. So here one problem statement is given. Take a process where a vacuum pump is required to be on for an interval during the process. The vacuum pump CR20 goes on after 8 seconds and runs for 7.3 seconds. The overall system, the CR17, continues to run after the time interval is completed. So now you can see that vacuum pump is so whenever the switch is on, the process is on, but vacuum pump is not going to be on at that moment of time. It is going to on after 8.7 seconds, and it will run for 7.3 seconds, and then it is going to off. But when the vacuum pump is going to off, the process is not going to be off. So let us how we can do that. Here you see, so whenever the system is on, okay, so on, it is on for a particular duration of time. At that time vacuum pump is not going to be on, it is going to on for on after 8.7 seconds, and it will be on for 7.3 seconds, and after that it is going to be off. Okay, so how we can do that one? So now here we will use two timers. So here if we will on if we will close the IN001, CR17 is on, so this is also going to be closed, this is also going to be closed, and this is also going to be closed. So now you can see that whenever the CR17 is going to energized, the CR20 is not going to be energized, because it depends on CR18 and CR19. Okay, so at that moment of time still the CR19 is off and CR18 is also off. So here even if the CR19 is true and IN001 is true, but at that moment of time CR18 is not true, so that's why vacuum pump is not going to be on. So it is going to be on only after 8.7 second, then the CR18 is going to be energized and it is going to be closed. Fine. And now what will happen, here you see, here this timer is going to be activated after 16 seconds. Why? Because here 8.7 and we have taken 7.3, for which it has to be on, so it is coming total 16. Then what will happen after 8.7 seconds, when the vacuum pump is on, then another 7.3 seconds this will run, and the TS19 is going to be energized. Once it is going to be energized, CR19 is going to be false, the vacuum pump is going to be off. Okay, and whenever the IN001 you will withdraw, okay, CR17 is or all the process is going to be reset. Okay, so in this way we can develop the ladder diagram what the problem is stated here. So that's all for the timer operation. With the timer, in this way we can develop the ladder logic. So later on we will see the timer will be used for other situations also. So next topic we are going to cover, that is counter. We will see that with the counter, timer is also can be used certain situation. So as the time progress, we will come to understand the different uses of timer more elaborately. Thank you.